This is the Steppr motor program, and it's been brought into the Arduino environment. So as we're taking a look at this, we see that we've got a include folder, and it's going to be called the Steppr. We have a constant that's been set up as so many steps per revolution at 1500, and it's also going to declare this variable Steppr and define it as going out on the pins 8, 10, 9, and 11. So we have a 4-phase Steppr motor, and we're going to set a signal out to each one of those pins. It will go through the void, which is going to clear the registers, and it's going to start loading my Steppr, which is set speed at a pre-selected value of 20. Once the serial port has been initiated, serial begin, it goes down into its subroutine of void, and so for the first part of the loop, it's going to go one revolution in one direction, go through there. It's going to send that signal out through the serial print pin. My Steppr is the declared variable step, and there's the steps per revolution which were declared originally. It's 1500, so there's now a delay, so they can stop, and it's now going to go into the second part of the program and go the other direction. So there's other direction and the same routine, and there's a delay. Then it comes back and it's going to loop around because it was declared as a loop. So it's going to go continuously work from one direction, go the other direction, and then repeat back again. So let's take a look down here at the board and see what it's doing. First of all, here's the Steppr motor itself. As it's a 4-winding unit, and it's going in one direction and goes the other direction. It's being driven by a conventional ULN2003 driver, and the signals for it are actually being derived from the LEGO Uno R3 module. Well, in this particular case then, here's the 4 phases, 1, 2, 3, and 4 going out. They directly drive the motor, and it works in between just these 4 lines here. The module itself is also grounded in connection with the power supply feeder, which is this module right here. This comes in from the main power supply module as 9 volts and converts it into 5 volts, which is going to drive the whole Steppr motor array. You'll also notice that there's oscilloscope probes that are here, and each one of these are going to be analyzing the phase of the signals in relation to each one. And we have all 4 phases that are going to be displayed right here on the oscilloscope. So number 1 is right here, and you'll notice it changes. It's going through one revolution and goes through the other. And this is also slightly out of phase here for this one, because the electromagnets inside of the motor are going to need an excitation for one phase. You're going to need it for the next phase to keep running the rotor all the way around the motor section itself. So each one of these are going to be slightly out of phase, and they go kind of down this. That'll be first, and then second, and third, and then fourth. And after this, it repeats. It goes back to one direction. It's going to go down through all 4 of these. It's going to stop, and then it's going to reverse the opposite direction.